So this is lesson 1 in exam 4. So this will be the last 3 video series that we have in this semester. So we're going to talk about proportional reasoning, and you can look at the objectives that are in front of us. So we're going to look at identifying ratios and then how to simplify them. And you can see that we're going to compare two different to determine a rate. We're going to find unit rates. We're going to determine if numbers are proportional. We're going to solve proportions. And then last, you see that we're going to look at geometric applications to proportions. So when we think about just what is a ratio, okay? And a ratio is what we're looking at comparing two items by division. Okay, so when we're comparing two quantities, that could be miles an hour, that could be ounces in dollars, whatever that is, we are comparing two quantities by division. And so we see it typically in this fraction form where we're comparing A to B, but we also can write it in a colon form, 4 to 1, or the word TO, so 4 to 1, or we see it in the fraction form. So those are 3 different ways that we can compare a numerator and a denominator, or compare two quantities. So if we had the greatest snowfall recorded in North America during the 24-hour period was 76 inches. So if we said, well, what's the ratio of the amount of snowfall in inches to time in hours? Well, notice what comes first, okay? The ratio of the amount of snowfall in inches, and we're comparing that to time. So we're really looking at what's in green to what's in purple. That's what our ratio is going to be, okay? So if we know that it's 76 inches and it was in a 24-hour period, well, now we're just thinking about, what is that ratio? We can simplify as much as we can as well, but this would be a comparison of inches to time. So we could think about 76 could be divided by 4. So we could say 4 and 19 are 2 factors of 76. And 24 could be 4 and 6. So these 2 factors would divide out, so we'd be left with 76 inches in 24 hours would be the same as 19 inches in 6 hours. So these are what we call equivalent fractions. And we're comparing amount of snowfall in inches to time. One game of a basketball series in the past, Indiana Pacers made a total of 64 baskets. Okay, so this is basketball. So a bucket also, we say 64 buckets or baskets. 29 were free throws and 27 were 2-point field goals. And the remainder were 3-point field goals, okay? So what we have is 29 and 27. 29 plus 27 is going to be 56. And you had a total of 64, which meant, that there's 8 3-point baskets. So 56 plus 8 would give you 64. So you got 29 that were free throws. You got 27 that were 2-point baskets, and you're going to have 8 that were 3-point baskets. Now, all of that should total up to 64. So 16 and 8 would be 24, there's 64. So we know it totals. So what's the ratio of the number of 2-point baskets to free throws? Notice that word 2 in between. Okay, number of 2-point baskets would be 27. And what you're doing is you're comparing that to the number of free throws, which would be 29. So 27 would be the 2 point, and 29 were the free throws. So 27/29 would be correct. And then if we look at part B, what is the ratio of the number of 3-point baskets to total baskets? And you can see the word 2. So 3-point baskets would be 8. We said that we had 8 3-point baskets. And then we have a total baskets would be 64. So that's your total. Well, 8 will divide 64, and that would leave you with 1 3-point basket to 8 total baskets. So 8/64 is the same as 1/8. Here we've got a screen that measures approximately 46 inches in diameter. So if you think about, okay, here's your TV screen, and we know that diagonally it would be 40 inches, and the height would be 22.5. And we'll say the width is 40. So find the ratio of width to height. So width is 40, height is 22.5. So notice what came first, width to height. So width is 40 inches, height was 22.5. So what I'm going to do is I'm just going to multiply both numbers by 10. So that's going to give me 400. Divided by, well, what's 10 times bigger than 22.5 would be 225. Remember, 22.5 multiplied by 10 is going to give us 225. Now, we can try to simplify. So we've got the 400 divided by 225. So we can actually divide them both by 25. So how many quarters are in 25, or how many quarters are in $4? That would be 16 quarters. How many quarters are in $2.25? That would be 9. So these would divide out. So you're left with 16 to 9. It would be 16 inches to 9 inches would be the width. Width would be 16, and the height would be 9. All right, so look here, we're going to look at simplifying some ratios. So on part A, 4 8/10 compared to 10. I'm going to do the same thing. I'm going to multiply by 10 divided by 10, which would be, that's my n divided by n. And so that's going to give me 48 divided by 100. And that will be able to simplify. So I think we have 12 and 4 and 25 and 4. Both of those would simplify. So you'd get 12 25ths as what, 4 8/10 to 10. If we're going to simplify that, we would do the same for part B. We're going to take 5 6/10 divided by 10. We're going to multiply by 10 divided by 10. So that gives me 56 divided by 100. And 56 is divisible by 4. So 4 multiplied by 56 would be 4 multiplied by 14, and 4 multiplied by 25. So the 4s would divide out. So you're left with 14 25ths, which would be the simplified version of 5 6/10 to 10. On C, I'm looking at 40 divided by 60. Well, these zeros will divide out because that's really 4 times 10 and 6 times 10. So I get 4/6, which can simplify to 2/3. And then 48 hundredths compared to 64 hundredths. Well, if you take 48 hundredths and compare it to 64 hundredths, you're actually dividing there. So you would really just end up multiplying by the reciprocal, which would make it 164th. So I'm just going to erase that. So these will divide out. So now I'm looking at 48/64, and both are divisible by, I believe, 16. So 16 multiplied by 3 is 48, and 16 multiplied by 4 is 64. Well, both 16 factors will divide, so you're left with 3/4. And 3/4 would be this simplified. Here you have some more practice. If you're looking at, you want to simplify ratios, try the two homework links. Next part of our objective is to be able to compare two different ratios with different measures, and also look at unit rates as well. Okay, so when we think about a rate, we're talking about a comparison again of two quantities, and those quantities could be multiple things. It could be that we're comparing miles to gallons, or we're comparing dollars to ounces. But what's going to separate this is that a rate is going to be different than a unit rate, because a unit rate will have a denominator of 1, and we're going to see that in just a moment. So a Toyota Sienna can travel 504 miles in 18 gallons. Well, I just want to know what it would be in miles per gallon. Well, if I can divide 504 and 18 and get that down to 1, that would give me 28 miles per 1 gallon. Okay, so what's in blue on the right is what we call a unit rate, because 1 is in the denominator. And what's in yellow over here is what we call just a general rate, because it's comparing two quantities, two different quantity values, like miles per gallon. But notice the denominators on the rate, it's 18. The denominator on the unit rate is 1. So suppose David's car travels 475 4/10 miles and travels on 16 8/10 gallons. Okay. Now this is a calculator module, part of the exam, so you can use a calculator to help you simplify that, but this would be 475 4/10 divided by 16 8/10, and what that's going to give you is about 28 3/10, if you round, miles per 1 gallon. So again, what's in yellow is the rate. The key is the denominator. That 16 8/10 is not 1. And then what we see in blue over here, this is your unit rate. And the answer and the question is why? Because 1 is part of your denominator. Okay, next question. We're looking at currently Walmart employees on average earn $470 in a 40-hour work week. So if you take 470 and divide it by 40, you're going to get approximately 11 75 for one. And remember, this was money per hour. So $11.75 per hour. And that was a couple of years ago where I looked that up, so that may have changed. But what you're looking at when you talk about minimum wage or whatnot, you're talking about a unit rate, that what a person would get per hour. Now you can look at unit rates per year, and that's when you're typically looking at an annual salary, where you're looking at what you would make per year. You can break that down to per month and per week and per day, even per hour. So a unit price or a unit rate, like I said, is when we are looking at a denominator of 1. So you see in the model, in the picture here, that models a comparison of a number to 1 in different units. So that could be the different units, could be miles per gallon, dollars per ounce, those types of different suggestions, or like students per classroom. So in the example here, it gave you 100 students in 4 classrooms. Well, what would that simplify to be? That would simplify to 30 students in 1 classroom. Well, this is a general rate, and this is your unit rate. And because it is simplified down to where the denominator is 1. Now, some other examples, I may ask you to find that unit price. If I give you different, I may determine, hey, what has the best deal, or what can you get the most per 1 ounce or 1 hour or 1 gallon? So in this case, I'm just going to call this, A, B, C, and D. So for A, we would say $2.49 per 10 ounces. Well, I'm dividing it by 10, so I know that that's going to be, I'm getting smaller by 1 place value, so that's going to be about 25 cents per ounce. And all of this will be per ounce. Part B, you have $3.59, and we're going to divide that by 16. So $3.59 divided by 16 ounces, and you're going to get about 22 cents per 1 ounce. And that should be more of a slash as part of your okay. All right, part C, we're going to have $4.09 per 20 ounces. So $4.09 divided by 20 should put us approximately 20 cents per 1 ounce. So right now, part A is the most expensive, where it's $0.25 per ounce. C and D, actually C is going to be 20 cents. I just rewrote that, sorry about that. So that's going to be 20 cents per ounce. All right, and then finally D is going to be $6.79 per 32 ounces. So what would that be per ounce? So $6.79 divided by 32 would put you at 21 cents per ounce. So the cheapest, looks like by a penny, would be the $4.09 per 20 ounce, puts you at right at 20 cents per ounce. You're paying the cheapest amount. If that was the question, it could ask you what was the most expensive. But if you can get items down to a unit rate, it's nice to compare. In this case, watering a lawn adequately requires 623 gallons for every 1,000 square feet of water. So what's the unit rate in gallons per square foot? So I want to take 623 gallons. That's going to be in the numerator. That's what I read first. What did I read second? 1,000 square feet. Well, 623 thousandths would be 623 thousandths gallons per 1 square foot. The heart of a human at rest beats an average of 4,200 beats in 60 minutes. What's the rate in beats per minute? So beats would be in the numerator, so 4,200 beats divided by 60 minutes. And 42 and 6 are both, 6 is a factor of 42, so this would actually be 70 beats per 1 minute. Now I'm kind of drawing a diagonal there. I would probably like to see this format, just your vertical format as well, or would rather see that format just because it is still a ratio, and it models the 4,200 beats per 60 minutes. So there's some practice with unit rates. You've got number practice when you also have some videos as well. All right, determining two pairs of numbers are proportional, and then we're going to solve proportions in these next few slides. So when we think about what is a proportion, a proportion is just comparing two ratios and showing that two ratios are equivalent. So when we take 1/2 is equal to 5/10, well, those are equivalent ratios, and those are also proportional. If you multiplied 5 by 1, you multiply 5 by 2, you get 10. So 1 times 5 is 5, 2 times 5 is 10, 5/10 and 1/2 we say would be proportional. So if I want to look at 1 to 2 in part A and 3 to 6, so notice I'm just comparing 1 to 2, 3 to 6. Is 1/2 the same as 3/6? Yes, they are proportional. B, I'm looking at 2 to 5. Is it equal to 4 to 7? And 2 multiplied by 2 is 4, but 5 multiplied by 2 is not 7, so it is not proportional. Part C, 3 to 4, is it equal to 6 to 8? Well, 3 multiplied by 2 is 6, 4 multiplied by 2 is 8. Yes, that one would be proportional. D would be 1 to 4 and 10 to 39. Well, 1 multiplied by 10 is 10, but 4 multiplied by 10 is 40, not 39. So 10 to 39 and 1 to 4 would not be proportional. Another method of checking to see if something's proportional is your cross products. And so if you take 9/15 equals x divided by 5, if I were to solve for x, I would multiply this side by 5 and this side by 5. So notice what would happen. I would have 5 multiplied by 9 divided by 15 is equal to x. Well, and then if I multiply both sides by 15, notice what I would get. 5 multiplied by 9 is the same as x multiplied by 15. I'm just wanting you to see that what I have right here would be the same thing as if you did your cross products over here in this example. 9 times 5, well, there's your 9 times 5. And then in yellow, 9 times 5, and then 15 times x. So cross products is another way to check to see if something's proportional, but you can also use cross products as a method of solving proportions. So in this case, you have 6/15 is equal to x 20ths. Well, if I wanted to solve for x, I could multiply both sides by 20. And that would give me 120 divided by 15 is equal to x. So what you're seeing right here is 20 multiplied by 6. Well, that's your cross product here. And then finally, we would divide by 15, which after you multiply the other cross product, you're going to get 15x equals 6 times 20. Notice that right here, you're seeing right over here. So we're going to multiply 6 by 20, and then we're going to divide by 15. So let's look at a few of these as we solve. If you want to do cross products, you can multiply 3 times x and 7 multiplied by 5. That's going to give you 35. Then we're going to divide by 3. So x is equal to 35 thirds. That would be a repeating decimal because 3 in the denominator would represent a repeating decimal. Here, we're going to multiply 7 and 7 tenths, multiplied by 2 and 2 tenths, and that's going to give me 16 and 94 hundredths. And then if I take y and multiply it by 15 and 4 tenths y, that's what I get. And so now I'm going to divide both sides by 15 and 4 tenths. And that's going to give this, that's going to go to y, and 16 and 94 hundredths divided by 15 and 4 tenths would be 1 and 1 tenth. Next, third one, I'm going to say 8 times 3 is 24. 5 times x is 5x. 5 will not divide 24 evenly. So 24 fifths would be a result. Or if you wanted to divide that, you would get 4 and 8 tenths as x. And then this next one is a mixed number. So let's take 4 and 2 thirds and divide it by 5 1/2. And we're going to set that equal to 14 divided by x. So 14 and 2 thirds, I'm going to go ahead and change this to an improper. Okay, so 4 times 3 is 12 plus 2. So 12 plus 2 is 14. 14 thirds divided by 11 halves. That's what 5 1/2 would be. And we're going to set that equal to 14 divided by x. So if we go ahead and do our cross products, that's going to be 14 thirds multiplied by x is equal to 11 halves multiplied by 14. So 14 thirds x, so that I'm going to come up here. So 14 thirds x is equal to, well, 2 will divide 14 7 times, so that would be 77. So you see this divide by 3? The inverse of that would be to multiply. So I'm going to multiply both sides by 3. And that would give me 14x is equal to 77 multiplied by 3, which would be 231. And then I just want to divide both sides by 14. So x is equal to 6 1/2. Another set is take 1 multiplied by x as I get x. 2 times 7 is 14. Answer would be 14. Same here, 5 multiplied by x, so 5x is equal to 3 multiplied by a third. And what's a third of 3? That would be 1. So divide by 5, x is equal to 1/5. Third, I'm going to take x, multiply it by 2, and get 2x. And then I'm going to take 7 1/10 and multiply it by 11. And I'm going to get 78 1/10. And what am I going to do with that? I'm going to divide both sides by 2. So on your calculator, you can take 78 1/10 divided by 2, and you're going to get 39 5/100. And then finally, I'm going to take 8 multiplied by y to get 8y. And I'm going to take 6 and multiply it by 2 4/10. I'm going to get 14 4/10. And then I want to divide both sides by 8. So I would get y is equal to 1 8/10. So there's your process, and there's some practice with proportions. Now these are just no context, so we're just working with naked numbers here. So you're just talking about doing cross products, and then so multiply, and then you'll see that you end up having to divide by something to get your answer. So here's some practice on solving proportions and some different videos. Lastly, we're looking at applications. So we're going to look at some proportions, some geometry, and work in some of the how proportions will work with our geometry application. So the readout on Matt's treadmill indicates that he burns 108 calories when he walks for 24 minutes. How many calories will he burn if he walks the same rate for 30 minutes? Well, there's a couple of things you could do here. You could take 30 and divide it by 24. And what you would find is it's 30 is 1 2500 times greater than 24. So that means that 24 multiplied by 1 2500, you're going to get 30. Well, then that means that I could multiply 108 by 1 1/4 as well. And that would give me 135 calories. Or you could take 108 divided by 24, set it equal to x divided by 30, do your cross products. So what is 108 multiplied by 30? That's going to be 3,240. 24 times x is 24x. So take 3,240 and divide it by 24. And what do you get? You get 135, and that's what we found up here. So a couple of different ways that you could, that you can solve a proportion. 2 shirts can be bought for $47, so maybe we could write 2 shirts. If I can spell shirts correctly. 2 shirts for $47. How many shirts can you buy with $200? Okay, so notice the proportion there. Now, I guess I could take 200 divided by 47. We would get an approximation. It doesn't divide very clean. So we could use cross products and just say 2 multiplied by 200 is going to be equal to 47 multiplied by x. So there's your cross multiply and then divide, because notice I've got to divide both sides by 47. So if I take 200 multiplied by 2 is 400 divided by 47, I'm going to get, I'm going to have to round a little bit, so it's going to get me about 8.5. So how many shirts can I get? Well, at least 8. I'm not going to take half a shirt. So how many shirts can be bought with 200? Well, I've got 8.5 as an answer, so I'm going to say at least 8 shirts. Well, I guess I would need to say at most 8 shirts. I do get 8.5 as an answer, but we're not going to have a half a shirt. So I probably need to change my wording there and say at most would be 8 shirts. We're not going to get 9 shirts. We're not going to have 8.5 shirts. So at most 8 full shirts. Mathematics instructor asserted that students' test grades are directly proportional to the amount of time spent studying. Brent studies for 15 hours for a final exam and gets a score of 75. At this rate, what score would he have received if he studied for 18 hours? So that's what you're looking for. So if I took 18 and divided it by 15, I would get 1 2/10, which means if I take 15 and multiply it by 1 2/10, I'm going to get 18. So what happens when I take 75 and multiply it by 1 2/10? I'm going to get 90 as an answer. You want to solve it the other way, and you have 15 hours divided by 75 score is equal to 18 hours to x score. Well, if I take 15 and multiply it by x, I'm going to get 15x. If I take 18 and multiply it by 75, I'm going to get 1,350. Now, if I divide 1,350 by 15, I'm going to get 90 as a score. So again, a couple different ways to do that. You're welcome to use the cross products. You can also use the division, like I said here. 18 divided by 15 gave me 1 2/10. Well, I just used 1 2/10 to multiply by 75 to get 90. Volkswagen Beetle can travel 495 miles in 16.5 gallons. How many gallons of gasoline will it take to drive 1,650 miles? Well, this would be a proportion. So I could say cross products of 495 multiplied by X and 1,650 divided by, or 1,650 multiplied by 16.5 would put me at 27,225. If I divide both sides by 495, that's going to put me at 55 gallons. How many gallons of gasoline will it take to drive 1,650 miles from Pittsburgh to Albuquerque? It would take 55 gallons. And then how far can the car be driven on 130 gallons of gasoline? So now you're figuring out a little bit different. Part B is a different question. But what do we know? Well, we know that there's 495 miles in 16.5 gallons. So we're just trying to figure out, okay, what about 130 gallons? How far can you go? Well, if I took 130 to divided it by 16.5, I'm still going to get a number that doesn't quite work out. I get more of a repeating decimal, and it's around 7 8 9/10. I can use the cross product, so 495 multiplied by 130 and 16.5 divided by X. So I'm just going to divide both sides by 16.5. And then over here, I'm going to say my answer X is equal to 495 multiplied by 130 is 64,350 divided by 16.5. And I'm going to get about 3,900 miles on 130 gallons. A college advertises that its student to faculty ratio is 24 students to 2 faculty, which is the same as 12 students to 1 faculty. That's really nice. If 81 students registered for introductory Spanish, how many sections of the course would you expect to see offered? Well, if we had 81 students, we're just trying to figure out how many faculty. Well, if you take 81 and divide it by 12, you're going to get 6 3/4. Well, 1 faculty multiplied by 6 3/4 is going to be 6 3/4 faculty. So we know we're going to have at least 6 faculty members to be able to do that. Roy bicycled 234 miles in 14 days. At this rate, how far would Roy bicycle in 42 days? Well, if I take 42 and divide it by 14, I'm going to get 3. So I know that 14 multiplied by 3 would give me 42 days. So 234 multiplied by 3 would put me at 702 miles. So what you're seeing again is two equivalent fractions. And if you took 234 and divided it by 14, you'd get about, 16 7/10 approximately. Well, 702 divided by 42 is approximately 16 7/10. Remember, the fractions ought to be equal and the decimals ought to be equal if it's proportional. On this next one, we know on a map that every 1/4 inch represents 50 miles. If two cities are 3 1/4 inches apart, how far is that in reality? So that reality part is in miles. So you can use fractions or you can use decimals with this. If you wanted to use decimals, the 1 1/4 would be 25/100 inches divided by 50 is equal to 3 1/4 inches divided by X miles. So if you wanted to do cross products, 50 multiplied by 3 1/4 would be 162 1/2, and then 25/100 multiplied by X would be 25/100 X. So we're going to take 162 1/2 and divide it by 25/100. And we should be getting 650 miles. In reality. All right, looking at some of the geometry pictures. Solve for the missing side length. So I'd like for you to know that C has 1 ring, F has 1 ring. That means that they correspond. That means they have the same angle measure. Look at angle A has 2 rings, angle D has 2 rings. Angle B has 3 rings, angle E has 3 rings. So looking for the missing length, I need to know what X is and what Y is. So notice that X is E to F, which is 3 rings to 1 ring. Well, EF is going to correspond to BC. So BC will correspond to EF. And we know BC, so BC is going to be 7, and EF is X. So I need to compare something else that I know, and that would be DE. Both D has 2 rings, E has 3 rings, so 2 rings to 3 rings, that would be DE, and we're going to compare that to AB. A has 2 rings, B has 3 rings, so that would be 4 to 6. So if you did some cross multiplying here, that would give you 42 is equal to 4x, and 42 divided by 4 is going to be 10 1/2. That would be the answer for X. Next one, I'm looking for Y. So Y is going to be DF. DF is 2 rings to 1 ring, so I need on this triangle 2 rings to 1 ring, and that's going to be AC. So that's going to be DF would be Y divided by 8 is equal to something that I know. So I want to compare back to DE and AB. So DE would be 4, AB would be 6. So Y times 6 is 6Y. 8 times 4 is 32. And if you take 32 and divide it by 6, you're going to get 5 3/10 repeating. So there's Y in green, and there's X in green. Here we've got 2 similar triangles. And so again, we want to solve for the missing. So I just need to look at what is going to be proportional, and that's going to be, I could take 6 to 8, and then I would do 18 to 24, but that doesn't help me because I need to look for the question mark. So what I've got to do is grab the question mark and 21. This is one way to do this. The question mark and 21, and then maybe these two. And then 6 to 18. So this would be 18 multiplied by x and 6 multiplied by 21. That would be 126. And when you take 126 and divide it by 18, you're going to get x equal 7. Or you could have taken, notice I did question mark to 21. I could do question mark to 8. So let me erase these just so we see what I'm comparing now. I could use question mark to 8, and then I could do 21 to 24. So question mark to 8, and then 21 to 24. See how I'm staying consistent. I did this one first, and then this one, and now I'm coming back to do this side divided by this side. So I'm going to take 8 and multiply it by 21, and I'm going to get this cross product here. I'm going to get 168 and 24x. So 168 divided by 24, again, I'm still going to get 7. And I knew that because we had already worked it. But this was just looking at another way and using different comparison numbers. So for 27, notice that I want to find x and I want to find y. So I've got to start with, let me start with what I'm looking for. So I want to look for x. So I want to compare x to something. Let's compare x to 4. They're corresponding. They're in the same spot. So let's do x to 4, but then I've got to compare two numbers, and these are the only sides where I actually know. So I'm going to do x to 4 and then 3 to 8. And then I could come over here and take y and compare it to 2. But then I'm going to have to come back and do the same thing and compare 8 to 3. So 8 times x is 8x. 4 times 3 is 12. And so if I take 12 and divide it by 8, I'm going to get 1.5. Here, for y, if I take 3 times y is equal to 16. 16. And then if I'm solving for y, I'll take 16 and divide it by 3, and I'm going to get 5 and 3/10 repeating for y. And then another picture is, notice we have two colors here. We're going to have PQS as a big triangle. And then we're also going to have TRS. So those are similar. T is going to correspond with P. R is going to correspond with Q. And then, of course, S shares the S side. So let's take what we know. We're looking for Y. So that's RT. So I'm going to take RT and compare it to QP. So I'm going to take RT and compare it to QP. So that's Y to 12. Now I got to compare it to something that I know, and I know 3 and I know 9. So I'm going to do 3 to 9, which is RS to QS. So 9 times y is 9y, 3 times 12 is 36, 36 divided by 9, y is 4. All right, so now I need to find x. Well, x is ST, and I'm going to compare ST to PS. And then I'm going to use RS and compare it to QS. So ST is, like I said, x. PS is going to be 15 plus x. And then I want to take RS, which is 3, and QS, which is 9 plus 3. So what I'm going to have here is x divided by 15 plus x equals 3 divided by 9 plus 3. So I'm going to have x divided by 15 plus x is equal to 3 divided by 12. So if I do cross products, I'm going to say 12x and 3 multiplied by 15 plus x. So I get 12x is equal to distributive property. 3 times 15 is 45. 3 times x would be 3x. And then if I solve for x, I'm going to scoop the 3x over by subtracting. That goes to 0. That's still 45. 12 minus 3 is 9x. Divide both sides by 9. X should be 5. And then just look at it. Just take 5 and substitute it in. So 5 divided by 15 plus 5, does that equal 3 divided by 9 plus 3? Well, 3 twelfths and 5 twentieths. Well, 5 twentieths will actually simplify to 1/4. 3 twentieths will simplify to 1/4. That just means that x equal 5 is correct. And then last one, I've got, I don't know the height of the tree, that's x. I know the height of the person, which is 4 feet 10 inches. And then I know the person's shadow distance is 5.5, and the entire tree, which would be 125. All right, so these are some things that I'm going to compare. I want to find x. So x is going to compare to the 125. So I'm taking the height of the tree and comparing it to the distance here, which would be 125. And then I want to compare that to the 4 foot 10 inches, which 10 inches is 10 out of 12, 10 divided by 12. So this is going to be 4 83/100 approximately. And the 5.5 feet, if you're I don't have inches there, I just have 5.5 feet. The height of the person was 4 feet 10 inches, so I just took the 10 inches and changed it to a decimal. So again, solving for the height of the tree, you can do cross products. That would be 5.5x is equal to 125 multiplied by 4 83/100, approximately 603 75/100. And when you divide by 5.5, 603 75/100 divided by 5.5 would be almost 110. So 109 8/10 feet, almost 110 feet using the proportions. So again, there's some practice with solving geometric proportions and applications, and you also have Khan Academy and Virtual Nerd as different examples there. So this will bring an end to Exam 4, Lesson 1 video on proportional reasoning.